Hello everyone, in this video I'll be talking about statistical analysis of output from terminating simulation model. I'll be demonstrating how to set up sequential modeling in order to get a specified precision interval for a particular statistics. For example, total cost for a system and or average total working process for a system and so on. As well as I will be showing how to set up PAN, which is an inbuilt tool in Arena where you can do design of experiment for your system in order to find better scenarios out of competing ones. So what is the motivation for statistical analysis? So we have seen that on the input side of our logical entity, a logical model, we usually use probability distribution as inputs. So if we fit in probability distribution to generate random variables for particular inputs, let's say arrival time or processing time and so on, it will lead us to having outputs which is random too. However, we can apply statistics and we can conclude whether the result that Arena is giving us based on the logic we expressed about the system as well as the input we gave is valid or not. So if you run a simulation model just for once, what does it mean? It just ran for one time and it's giving you average time about working process, about total time in the system and so on. So the value that you are getting, whether it's typical or not, we have no idea, right? So we have to rerun it a couple of times. So we can have sufficient statistics that we can build confidence interval on, and then can say that, okay, with 95% confidence level, I can say, yeah, this statistics can lie between this upper limit and lower limit and so on. And why we need this? Because there are also variabilities between run to run, between simulations. So across replication, there is also variability. Within replication, there is variability. So it all adds up and so on. That's why we need statistical analysis of our output data or output result. So from a single model configuration, we can do statistical analysis on it. We can compare two or more different configurations of the same model and then see which one works best based on statistical output. As well as we can search for optimal configuration, that which configuration will work best, as well as we can control these statistics that my half-width shouldn't go beyond some threshold. So we can do all of this in Arena. And it's pretty simple. So and one more thing, statistical analysis of output is often ignored. However, this is a very big mistake, and you should always, as you're feeding random input, you are getting random output. That's why for validation, you always need to do statistical analysis on your output. Not hard or time consuming, we will get to see that. It's pretty simple. If you define your logical system in a well-defined way and easier way, it's just like picking the things and putting it into a funnel where Arena will run it, and then you will be getting a good, valid conclusion about your system. It just takes a little planning and thought and some cheap computational time and so on. All right, let's proceed. So time frame of simulation is divided into two classes. Either it's terminating, where we can specify a particular starting and stopping criteria. Run length is well defined. So we'll say, okay, a bank is operating from 9 a.m. till 5 p.m. So it's like 10, 11, 12, 1, 2, 3, 4, 5, 8 hours of operation. So you'll specify that the replication length should be 8 hours. And then you can also specify if you have certain terminating condition to follow along with time in terminating condition blank inside run setup. So that's one class of time frame for simulation. Another class is steady state, or technically long run time frame for simulation model. Sometimes the analyst or the manager, whoever is governing the project, wants to know how the system would behave in long run, or what would be the output for steady state condition. In that case, we usually run it for very long time, but we can't run it like for infinite amount of time, right? So practically it's not possible. It will still have a definite terminating condition, but the run will be really long. And we'll see that in another video maybe, how we can if we have a very long run, we can see that there will be initial biasing when you run the model. So how to overcome that? So usually we use warm-up periods. So in that part of time, we don't collect any statistics about the system. But when the system reaches a steady condition, we usually collect statistics, whatever statistics of interest we are interested in about the system. So this is the two conditions. So in this video, we'll be talking about statistical analysis for the first part, terminating condition. There is a big question, so should I run my model, simulation model as a terminating condition criteria, or should I run it for steady state? It really depends on the intent of study. Just to know how your system would operate, let's say you want to know about the operational level, about the system, and how different processes will react and everything. In that case, in those kind of criteria, you usually use terminating condition. But if you want to know long run behavior of a system, let's say long run behavior, let's say throughput, steady state throughput for a system, or steady state steady state working process for a system, and so on, for a particular process maybe. In that case, we have to use steady state terminating steady state time frame for simulation. Sometimes it's not clear which is appropriate. In that case, you can run both because you'll be using the same logical model. It's just how you are specifying the ending time or terminating time of your simulation. So here we will be doing the first one. Strategies for data collection and analysis. For terminating case, we make IID replication, independent and identically distributed replications. So how we can do that? We usually go to run, go to setup, go to replication parameter, and then initialize number of replication field to maybe 5, 6, 7, or whatever number of times you want to do the replication for. And then we usually check the boxes for initialize between replication. All right, so now I'm gonna open Arena. I'll click here. I'll go to run setup. So that's what I'm talking about. Let's say I have a bank that operates between 9 a.m. till 5 p.m. So replication length is 8 hours. Hours per day is 8 as well. And then maybe we just want to have the base time unit set at as minutes. Next, let's say I want to find out how the bank is going to operate for 30 days. And each of these days statistics must be identically distributed, independent and identically distributed. In that case, we will initialize the number of replication box to 30. Next, over here it says initialize between replication. So I want independent IID replication. So I'll always check this two boxing. What does these two boxes specifies? First one is statistics. So if you check it, starting of every replication, all the statistics means how statistics are calculated. Usually Arena has system variables or user defined variable. Those are used to count or calculate the statistics, right? So beginning of every replication, all the statistics will be wiped off. So Arena will keep a track for statistics for each replication. However, statistics will not be carried from one to another if we check this box in. Now, if I uncheck it, statistics will pile up. Let's say in replication 1, there were, let's say, 15 entities that went out of the system. So in replication 2, let's say 10 of them went out of system. So when you open your category overview report, you will see in the entity output section for your replication 2, the number is 25. It's not 10. So what it did, it add up 15 plus 10 and put 25 there. So it just piles up all the statistics. So usually when we are doing terminating simulation analysis, we usually check both of these boxes. How about system? So after setting up everything, we initialize the system. When we first hit run, everything gets initialized. What does this mean? That means there is no entity that is in the system when the simulation run. Those are in the system when the simulation run starts. So if you uncheck it, so from replication to replication, you might have entities that are being carried with them. Why? Because if you uncheck this box, let's say the first replication is running from 0 to 8 hours. Then the next will start from 8 to 16 and then 16 to 24 and so on. So it's like the time is flowing one after one. Like it's continuous. It's not like, okay, it's 0 to 8 and now back from 0 to 8. It's like 0 to 8 and next one is from 8 to 16, then 16 to 24, 24 to 32. And why I'm getting this 8? Because I referenced 8 over here. So that's what happens if you check and uncheck these two boxes. Set up a very small model and try to play with it. Like first, like make 5 replication maybe, and then go ahead and initialize the boxes, like check both boxes, then uncheck one and see what the category overview report generates for you for that simple system. In another video, I might come up and demonstrate with a very simple model what these two boxes does. So that's one small thing I wanted to mention. And the other one is, so we have done models where we have used replication length to specify how long the simulation should run, and we have also used terminating condition. Now, let's say you want to terminate your model based on terminating condition. Let's say I want to run my model for 8 hours, but I want to flash out all my entities within the system before it stops. So in that case, if you specify 8 here, and if you specify that, okay, T now should be greater than or equals to 8 if your base unit is in hours, and their total entities in process should be 0. In that case, maybe it might take more time than 8 hours, right, to flash out all the entities. However, as you have specified 8 here, what will happen is that Arena will run up until 8 hours and then it will cease. So if you put some value in your replication length as well as terminating condition box, whichever is met first, whichever condition is met first, Arena will pick that up and then terminate your simulation. So always use either of them depending on your intent of your study. All right, so that's one thing. And Over here, we can see a blank called warm-up length. So when we'll be doing steady state simulation modeling, we'll be using warm-up period because we want to avoid the initial biasing of the statistics when we run the simulation model. Let's talk about that in another video. Okay, now I'll go back to the slide. So over here, as we can see, the call center model that I built So in another video, I have demonstrated how to set up a simple call center model, and the model scenario was taken from Simulation with Arena textbook. So I'll go back and open that model. I'll go in and then open the model. So over here, I have set up the model. Next, so what happened into this model? I just want to give a small brief. So this is a call center model. So calls were getting in, and then based whether there is a trunk line available or not, calls were moving forward. And then coming here, and it was like after a call gets in, it sees as a trunk line, and next the caller usually listens to a recorded audio clip, like why they are here, which menu they need to select. So based on their motive, they're being directed to either technical call department, or sales call department, or order status call department, from where they had where the call center had different resources to take care of the call. After that, when that's completed, some of the technical call required to some back office research, like the agents who were supporting the callers required some additional time to solve their problems. So what was happening is that they used to hang up from the caller. So caller used to put down the phone, and then the agent used to do some research, and the researching time was exponentially distributed with a mean of 60 minutes. After that, based on what type of product it is, the agent used to seize the trunk line with a higher priority than the arriving incoming call, the new incoming calls. And then they used to call the caller and then provide the appropriate support and release the trunk line, and so on. So that's the basic concept of this model. However, so what was done additionally is that there were two counters set up. One counter was tracking the hourly rejection calls in this call center model due to having less number of trunk lines. Due to having trunk lines busy, to be more specific. So let's go ahead and run the model first. We'll fast forward it, and then we will get to see that based on the hourly rejection rate, the call center thought to hire some new employees. So how many of these new employees they need to hire to reduce the rejection call rate? That's the motive of our statistical that's the motive of our this video. All right, so I'll go here, and then I'll go to user specified, and I'll go to counter. So over here, we can see that the rejection rate or call dropping rate was highest from hour 4 to hour 8. So between these 4 hours of operation, maximum numbers of calls were getting rejected because of unavailable trunk lines. So that's why the call center thought they might hire some additional staff. So what we did is that we went to variable, and then over in variable, we created 5 new variables called new tech 1, 2, 3, 4, 5, and so on, as well as salespeople. And then we initialized their value to 0. because the call center actually doesn't know how many new Tech 1 employees they need to hire, how many new Tech 2 employees they need to hire, or how many sales they need to hire. They want to hire it. So they're like depending on the simulation model, how many of each additional resources they need to hire. However, they have a limitation. They have a total budget of, I think so, $13,000 that they can maximum spend of hiring new people. So we'll get to see like which scenario works best. Do they need to hire? Is it better to have more trunk lines, or is it better to have more tech people or new sales people? That's what we will do using Process Analyzer. Or in UpQuest, we'll get to see, maybe in another video I'll show like what should be the optimal number of employees that needs to be hired in individual categories and how many trunk lines they can add so that it satisfies the total amount they have available, as well as it satisfies the number of rejection call rate to a certain threshold that they want. Okay. So we have that here, and then what we did is that we went to resource and created 4 new resources: Larry, Mo, Carly, and Harmon, like this over here. So it says like Larry. So that's a little funny that the book outlined that all the new additional new Tech 1 employees name might be Larry, just to make it simple. They did it. And their schedule is also declared over here. So they will be available from like, so in the starting they won't be there. So after so they will arrive exactly after 4 hours of operation, and they will stay there for 4 hours, and then they will leave. So over here the capacities time unit is in half hours. So that's why it's like 8, 8, and 6, the durations. All right, so that's the overview of call center model. And then I want to show the statistics that we are collecting here too. So 2 of the statistics we'll be using often next. First one is total cost. So total cost is an equation that is written here. It considers the cost of new resources, as well as it considers the cost of excess waiting time in each of these individual processes in tech department, sales department, and order status department, as well as it considers the total fixed cost for staff salaries. And over here, the other one is percentage rejected. So how many calls were rejected? So we'll be using these 2 statistics to find out how many new employees we can hire in each of these divisions and which works best when we are considering this 2. Okay, I'll go back to the slide. So after running 10 replication of this model, this is the reported total time and percentage rejected for each replication. So what we can see, so I'll go back to Arena and show you one more thing. So if you go to reports, so usually we use category overview report, right? To find out user specified values or whatever stat we are looking at. So inside category overview report, what happens if you are running your model for more than 1 replication? In this area, you'll find the average of all the statistics in this from these 2 replications. But if you want to know what happened exactly in each of these replication, you need to go to category by replication section. And then if you click over here, you'll find the statistics that has been collected for individual replication. So if I go to output, so for the first replication, the total cost was reported to be $23,901.31. And the percentage rejected is reported as 15.5951. For the next replication, the total cost was reported to be 20,452.12 and percentage rejected was 14.6309 and so on. So that's what was reported for all these 5 statistics. So if we run the model for 10, let's say, so this is the table that has been generated from there. What we can see, the first thing we can see is that there is a significant variability across replication, right? So we can see for the first one is 22,000 and rejection rate is 12.2759. For the next one, the cost came down and as well as the percentage of rejection came down. So by looking at it, we can't make a decision. Okay, so I should take the statistics that has been reported in replication 5. So whether I need to take it from each replication or whether I need to do a average for all this and collect the statistics from category overview report. So next, over here, we have to think about, so we know that there is variability across replication. So how many replication is sufficient to make a statistically significant result? How we can find that? So there are 2 ways to do it. The first one, you can do an approximation method. You can apply approximation method and find the acceptable number of replication that you need to go up until you have reached a satisfied precision level for a statistics. Or you can hand it to ARENA. You can hand it to ARENA through a method called sequential sampling, where ARENA will find out, okay, so so the analyst want half width to be less than, let's say, 0.5 for a particular statistics. So after running it couple of times, did the half width fell below that? If so, it will terminate the simulation. If it doesn't, then it will keep on running. So now we are going to build a sequential model for this call center model and try to find out how long it takes for ARENA to give us a particular total cost value within a certain precision interval. All right. And if you are running it for long, always it's convenient to use batch run, where there will be no animation. And before going to sequential sampling, if you want to find the approximate number, instead of creating that logic in ARENA, you can use the formula for confidence interval. So this is a very simple formula. Like this is the universal formula for confidence interval. So you'll have your statistics plus minus t statistics times sample error over standard error over root over of n. N is your sample size. So this gives us the half width. And then what we can do is that we can manipulate this part to find how much we need to increase n sample size so we have a desirable half width. So this is the formula of doing that. So if you just interchange the sides for these variables, if you take n, which is the unknown in this case, on the left hand side, on your right hand side, so over here it says t statistics. However, t distribution is dependent on n, right? And we don't know n. That's why, let's say we assume that the sample size will be more than 30 to get the desired half width we want. So we replace t statistics with t distribution with z distribution. And over here, we assume that the sample standard deviation for the initial condition is same as the one that we are searching for. So these two factors are assumed that they are held fixed, and then we try to find out the half width. And there is much easier way to do it. What happens is that if we divide n0 of this formula over n that we're trying to find, we'll come up with this simpler version where we will not require to have sample standard deviation as well as z statistics. So it's like n is approximately equal to n0, the initial replication sample, times h0, which is your initial half width, over the half, so over the desired half width that you want to achieve. And then you'll be given with the approximate number of replication that you need to do in ARENA. One thing, it's important here that n grows quadrically as h decreases. So let's say you want to reduce your h by 4 times. So n will increase by 16 times because that's their relation. Because if you held all this fixed, n is inversely proportional to h. All right, so that's the approximate way to find it. Let's go ahead and see how we can deal it in ARENA using sequential sampling. So we are back into the call center model in ARENA. I'll create a new box here. And then I'll just copy one of this text and put it there. And name it sequential sampling logic. Next, I'll go to basic process. I will get a create module. And then I'll get a decide module. I'll get a assign module. And then I'll get a dispose module. I'll take off the connections here. And then I'll start editing the create module. So we'll be creating a logical entity here that will take care of assigning the maximum number of replication when half width has reached for ARENA. So we'll name this model as create logical entity arrival. Entity type is logical entity. And then we really want to produce one of it. However, we will initialize the value to a very large number for time between arrivals. And then always select the unit as minutes or whatever is your base unit whenever your simulation run is going on. And then maximize arrival to 1. So one of these entities will be created exactly at 0 minute for each replication starting time, during each replication starting time. I'll click OK. Next, it will enter a decide module. Okay. So usually we need more than one replication. Usually we will need more than one replication to perform sequential sampling, because for terminating condition, it usually runs between 8 to 10 hours. By that time, ARENA doesn't have sufficient number of samples to generate a confidence interval and a half width. So usually run it beyond more than one replication or more than, let's say, 2 replications. So if the number of replication is 2 or less, ARENA will keep on running. If it is more than 2, at that time it will check a criteria. We'll define that here. Let's go ahead and do one thing. I'll hit save. And then I'll go to my report. And then I'll go to category overview report. Then I'll go to user specified. And over here, I'll go to output. Okay. So the half width for the total cost right now is 1535.11 units. Okay. So if I want to reduce it below 800, so how long I have to run? So I will just go and tell ARENA that I want a half width for total cost to be less than 800. So run the model up until that time. That's what we will do. So I'll go back to the model, and over here, I'll go inside decide module. I'll name it run simulation. And in type, I'll select n-way by condition. The first condition would be based on expression. So then over here, I'll come by and go to build expression. Here, I'll go down to replication variables and I'll say if the current number of replication is less than or equal to 2, keep on running the model. So that's the first logic, because I will connect this end to dispose. So nothing will be changed by this logical entity. Next one, I'll say I'll define it using expression again, but I'll go to build expression. And there is an inbuilt function in Arena called orun half. All right, so you orun half, whatever stat you put inside, it will return the half width for that statistics. So we want the half width of a user specified statistics, which is defined under advanced process panel. So I'll go inside stat, I will go inside output tab, I'll go inside and select last recorded value for total cost. Okay, so we don't want last recorded value, we just want the name of the statistics. So we want the half width of total cost statistics to be less than equals 800, right? That's what I mentioned first. However, if I say less than equals 800, what happens? Whenever it achieves this, what will happen? It depends on the connection we are doing. For now, I'll just initialize like this should be bigger than 800. So if it's larger than 800, what will happen? Nothing will happen. Arena will keep on running the simulation model. It will do more replication. However, whenever it reaches below 800, it will stop. It will change one more inbuilt variable of Arena to a different value. So we'll write this and we'll click OK. So that defines, I'll just zoom in, that defines our decide module. Next, I'm going to connect the first output of decide to input of dispose, and I'll do the same for the next one. And then I will fix this assign module. I'll name this as reassign reassign max replication to current replication. And then I'll go inside assignment and then I'll select other, and then in other I'll go to build expression. Then I'll go inside replication variable and I'll say maximum replication should be the value of the current replication. I'll go here and I'll select it. So what it does, let's say the replication has run up until, let's say 10 times. And now what Arena will do is that it will assign maximum replication to be 10. So when the next replication start, Arena will come by and see, okay, I have ran up until I'm required. So it will stop running. Then I'll click OK. Next, I'll just connect this part to this assign and then this to dispose. I'll name it dispose logical entity. So the sole purpose of this entity is to check these two conditions here, and then if these two conditions if these two conditions are not met, then it will come by here and reassign the maximum replication length to the current replication length. And when it will be achieved when this criteria, that the half width for our statistics is beyond a required, like when it's not beyond a required value, then Arena will say, okay, maybe the user specified threshold has been reached, and then it will stop running. So I'll click OK, and then I'll I'll go to files and then I'll save this model as save model 6.1 and then hit save again. And then I'll go back to run parameter. And over here it says 5. So let's say for bringing down the half width to a smaller value like 800, Arena needs to run for 100 times. Let's say 100 replication. So if I put 5 here, same as replication length, connection between replication length and terminating condition. So 5 is less than 100, right? However, if we specify 5 there, Arena will cease after running 5 replication. It won't follow the logic that has been declared here. So what you need to do is that really initialize the replication length to a very large value and then let Arena decide how long it should run and then terminate. So let's say we will initialize it to 10,000 and then I'll click OK and then I'll hit save. Next thing is that I'll go to run again and make sure that batch run is selected. I'll hit save again and then run my model. So here we can see the replication number. So it's running up until 9, 10, 11. Let's see how long it will run to achieve such a small half width. So it ran for 15 times. Let's go ahead and hit yes. And then I'll go to user specified output total cost. So over here you can see the half width has come down to less than 800, right? That's what we asked. So it ran for another time to make sure like what. So what happened is that Arena ran for how long? Up until 15th replication. So let's go to category replication. And let's see what happened to the total cost half width during replication 14th. So I'll go there, then I'll go to output, and then I'll come back. So over here, okay, so it just reported the value, but it didn't specify the half width. Let's do one thing. I'll close and then I'll try to do a thing. I'll go to stat and then over here I'll try to create a new statistics. Double click, I'll call it cost total cost half width. And then this is the output statistics that we are collecting. Why output? Because this data will be collected at the end of replication. That's why output. I'll go to build expression and then I'll write O run half for total cost. And then click OK. And then click one more time OK. I'll hit save and then I'll run the model. And then it will run for 15, but this time I think in the user defined section of our report, for each replication we'll have the half width for total cost separately. So I'll go to category by replication and then let's go to replication 14, user specified output and then half width. Yes. So here you see. So half width for replication 14 was 800.2.46 up until replication 14th. So in replication 15th, we achieved the output or the half width to be less than 800, right? 744.84. So over here, if we go back to our logic, what we will see? The second expression says that the half width if the half width is more than 800, logical entity will get disposed. It will not come in here and change the maximum replication length to be the current one, right? So that's why we have this tree logic. And the first one is merely there to make sure that the whole model doesn't get terminated before having two replication, because you will need at least two replication in case of terminating simulation model to generate half width in most cases. That's why we have it there. So that concludes the part of doing sequential sampling. And then we'll save this model. Next, we'll go back to the PowerPoint. And then we'll start looking into other things. So next, we're going to evaluate many scenarios using process analyzer. So if you recall, we have created certain variables for additional stuff, for defining additional stuff numbers into the model. However, we have initialized them to 0, right? So we need to change those numbers and see how the total cost of the simulation model changes and how adding additional stuff changes the percentage rejected for the calls and how it affects the total cost. So let's go and start process analyzer in Arena. So right now I'm in Arena. One thing I'll be doing here is that I'll take off the sequential logic model right here because I'm going to fix my number of replication to 10 in the beginning. I will show you why. I'll just take off this and then I'll save this model as model 6.2. Okay. And then I'll go to run and then I will change the number of replication to be 10. Rest remain same and then I'll click OK. Next, I'm going to run this model one time. So before starting process analyzer, make sure you have ran your model at least once. And then we don't want to see the results of this replication because we're going to use process analyzer. Okay, so then I'll go to tools, then I'll go to process analyzer. So this is how the interface looks like. It's very basic. So we'll go to file and then we'll hit new. And then we will save this file inside the folder where we have saved our DOE file, the model file. Let's just name it model 6. And next, what we're going to do is that I'll double click here to add a couple of scenarios. So the first scenario we will name as base scenario. That means there is no additional resources. All right. And then this is the tip name. This is like if you hover your mouse all over, this tip name will be showing up. Let's just keep it like it as it is. And then we have to browse a program file. So we have to upload a program file called p-file to reference Arena model into this PAN file. So whenever you have saved your DOE file, you have seen there are at least 5 categories of files that automatically gets created. It's like you are creating a project. So over there, you'll find the P file. Make sure it's a P file that you are uploading in PAN. So, and the P file with the same name as your model for which you want to create this PAN file. So over here, I can see model 6.5. Here is the P file. I'll upload and then I'll click OK. So over here, I have my base scenario. So what we will do next is that we'll just hit, let me do it one more time. Over here, if I move my mouse, I'll just select this row. Next, I'll go to edit and I'll say duplicate scenario. So we'll have duplicate 1, duplicate 2, duplicate 3, duplicate 4, duplicate 5, and duplicate 6. Because we are going to alter the number of additional trunk line, the number of additional take 1, take 2, take 3, and then additional cells. All right. Next, let's rename these scenarios. The first one is base scenario with no additional stuff. The next one would be add trunk line. So we'll be adding trunk line. Next one would be add new take 1. And then the next one would be add new take 2. Add new take 3. And then add new take 4. The last one is add new take 5. And then the last one, okay. I will say I'll select it. Oh, sorry, not new take 5. Okay, I got carried away. So add new take all. And then the last one is add new cells. Next, what we will do is that we'll go to insert and we'll insert control. So there are two things here. One is control, one is response. So control is our independent variable that we can change, and control and response is the dependent variable. Based on this, this is your response statistics. So what we will control in the first base scenario, let's say we will go to user specified. Next, let's go to resource first, sorry. Let's go to resource and then we will select trunk line. So after I select a trunk line, it says what kind of data you will be importing. Is it a real number or is it an integer? Let's just say integer and then click OK. So over here in our model, we have 26 trunk lines so far. So you can see 26. Trunk line has been initialized to 26 as capacity. Next, we'll add more control. I'll go to user specified and then I will click new take 1 and then control new take 2. See, all are zeros because their values are 0 in our model. Then new take 3 and then control, sorry, not response, should be control. And then new take all and then new take, the last one is new cells. Okay. Next, let's go back to our PowerPoint slide. Sorry, I'll go back to the slide. Okay. And then over here, okay. So over here, we will say that the call center has a fund of $1,360 more per week for resources. So if we have $1,360, we know that the flat rate for running a trunk line is 98. So if we divide 1,360 over 98, it's approximately 13 trunk line that the company can have in addition to the 26. And then the if they hire new tech people, take 1, take 2, or take 3. So if you divide 1,360 over 320, which is their weekly salary as part-time staff, they might have 4 of new tech people, either 1, 2, or 3. But for new tech all, they're more skilled, so they will be paid higher. So 360 is their wage for each week. So if you divide 1,360 over 360, you'll find that you at most can hire 3 new tech people who is specialized to provide tech support for all kinds of product. And then same for sales. So 1,360 over 340. So if you divide it, you'll see that you can hire at most 4 salesperson. So we are gonna go back to our PAN file. So in here, for the second scenario, let me just go ahead and try to do one thing. I'll just try to make this things a little bigger. See, it's easier to see. Okay. Next, so the first scenario, we said we will be adding new trunk line, right? So instead of 26, what we will do, 26 plus 13 is 39. So say now, Arena, my capacity of trunk line is 39. Run it and report back me my statistics. I'll write the responses after this. Then the next scenario says add new tech staff. So at most you can hire 4 new tech 1 person with the given budget. At most new tech 2. At most you can hire 4 new tech 2. At most you can hire 4 for new tech 3. At most you can hire 3 of 3 new techs who can provide support for all kinds of products. And for sales, at most you can hire 4. Okay, I think 4, right? I'll just go back and double check. Yeah, 4. So next, what we will be doing, so we have our control defined here. Next, we'll be defining our responses, the dependent variable. So we will go to user specified, and then we want to make decision based on the total cost to operate a call center for every week, and then the percentage of call rejection. So that will be another response. So I'll go back to user specified, and then I'll go down to, just a minute, rejected calls, sorry, percentage rejected. So based on this value of the two statistics, we'll try to find which scenario works best. One more thing, instead of like utilizing all the money behind one resource, hiring like having only trunk line or having only take type 1 or take type all our new cells, you can do this like matchings. Let's say, what will happen if I spend some money for adding new trunk line, let's say 5 trunk line, 1 new tech agent, or 1 or 2 sales agent, and so on. So there will be, so how many variables we have? 1, 2, 3, 4, 5, 6. So there will be a lot of combination that we can apply to find out which works best. So we'll be using another application of Arena called UpQuest, where we can define this as mathematical model, and Arena is going to generate the optimal solution if there is for a particular problem. Okay, for now we are assuming that we'll be investing, we can only invest in one kind of these resources. Either we'll hire tech 1, take 2, or take 3, or take all, or new cells, or we are going to add only trunk lines, and so on. Okay, so we have all the scenarios here. I'll go ahead and hit save first. And then I'll press Control on my keyboard. So, and then I'll be selecting all these rows over here. Next, I'll hit this small triangular button called Go. After I hit that, I'll have all this, and Arena will ask, do you want to run all this scenario? Yes, right? So I'll hit Control again, and then I'll select all the scenarios over here. And I hit Control, I selected Control, I'm still holding it, and then I'm selecting all the scenario one by one. And then I'll click OK. Next, so over here you can see Arena is running by itself. We don't need to go back to DOE file to run it. So it automatically runs the model by itself. Let it finish running. Okay, it ran. So all the 1, 2, 3, 4, 5, 6, 7 scenario ran. Next, so let's see one by one. How does the value looks like? So for call rejection, the best scenario is so far looking like Adding new take all would reduce the rejection rate. However, how about our cost? Yep, for costing, it also looks the best. So in Arena, in Process Analyzer, you can find one more really important thing. So for that, we can insert charts. So let's go ahead and select one of this output statistics. So I just selected that column and then I hit right click on my mouse and then I am going to say select insert chart. So insert chart, you can see you can create column, bar, 3D columns, box and whisker diagram, 3D lines, and so on, whatever chart you want to plot for this statistics. And over here, what it says, compare the average value of a response across scenario, or you want to compare the replication value of a response for a single scenario. So we'll select the first one. Compare the average value of a response across scenarios. So we have more than one scenario, right? That's what we are comparing. Let's select box and whisker diagram. This is like box plot. Click next. So let's do it for the first one. And then I'll hit next. Over here, yeah, I want to label my x-axis. And here it says identify best scenario. So I'll check that in. So is bigger better or is smaller better? If we have, we want to minimize cost, right? That's why we'll select smaller is better. And then automatic defaulted error tolerance is here of a value of 698.969. So what does this error tolerance means? That the best scenario that will be shown here might have a certain error of this magnitude from the real best one with 95% confidence interval, confidence level, we can say that. I'll hit show best. Okay. So see here, instead of 7, now we have 4 scenarios, right? Which has been found by PAN or Process Analyzer as the best scenario. However, if we want to further narrow it down, what we can do, we can increase this error tolerance. Let's say we are talking about $20,000 or $22,000 a week. So $800 difference won't make much. So let's say I'll hit 8, I'll select 800. So one of the scenario has gone. However, still we're left with 3 of it. So 2 ways to get more precise estimation. And why we have this? Because we have variability across replications, right? That's why it's hard for PAN to analyze these results based on smaller sample size. If we want to increase our sample size, what we have to do, we have to run our simulation model for a longer period of time. So that's what we will do next. And then we'll try to find out whether running the replication for a longer period of time makes it easier to find the best scenario or not. So I'll hit cancel for now. And then what I will do is that I'll go back to my Arena model. I'll hit save. And then here I'll go to run. So instead of 10, I'll run it for 110 times. And then I'll click OK. I'll go to run and I'll see, okay, batch run is selected. And then I'll click run. So the whole model will run for 110 times. So I'll pause the video and start it when it stops. So it ran for 110 times. And next I'll click no, because I'm not interested to know the results. However, I'll hit end. So make sure if you change something in your model, then Arena doesn't automatically reset it inside PAN application or Process Analyzer application. So I have to go back here, open this file, and then I'll hit Control. I'll hold Control on my keyboard and select all the scenarios one more time. And then I'll go to run and then I'll hit reset. So do you want to reset all? Yes, I want to reset everything. And then I'll hit save. After that, I'll hit go one more time. And then I will select control on my keyboard and then select all these scenarios one more time. And then I'll click OK. And now Arena is going to run the model. The process analyzer is going to run the DOE model with the change that you just created. So what did I change here? I increased the replication to 110 from 10. So it will run for all the scenarios. So I'll pause the video and I'll come back when all the scenarios has been ran for 110 times. Okay, so all the run completed for all the 7 scenarios for 110 replication. Next, I'm going to select the statistics. Let's say cost. I'll select insert chart. I'll select box and whisker diagram, and then I'll select next, and then include rows between scenarios. So after having a lot of statistics, we can see that what happens is that smaller is better, right? So if the total cost is of smaller value, then it's a better scenario. So over here, what has been suggested is that the base scenario is the best one because it has the minimum amount of cost associated. Okay, but we can see straight away the two comparing scenarios are base and the last one where we were adding salespeople. So for the base scenario, you can see that the cost is 21,715.311. Rejection rate is 11.608. However, with just an increase of $50 or so, we can see the percentage rejected rate is lower. Okay, so over here, let's say the error tolerance, we set it to 0. And then see, if we set the error tolerance to 0, we have two competing scenarios which are battling with each other to be the best. So let's just say like we don't care about $50 and see what happens. Still, let's say we don't care about $250. Still, let's say we don't care about 500. So plus minus 500. In that case, base scenario is selected as the best. So I'll hit finish, and here we can see a box plot has been created by Arena for us. I'll just extend this part and see from here significantly base scenario is working best in this configuration. Okay, next let's see what happens if we do the same thing for percentage rejected. Which scenario is being selected as best? I'll hit chart, I'll select box and whisker, and now I just want for percent rejected. I'll go to next, I'll say yes, I want the x-axis, and then smaller the better this time, right? Okay, so if I have error tolerance of 0.42872, there are 3 good scenarios. So let's say if I increase it, that I don't bother about 0.8%, then still we have 3 scenarios as best. So either we can increase the error tolerance to a larger positive value, or we can do more replication. In that way, the best scenario will get isolated. But for now, let's just hit finish. So we'll have 2 charts here. And then if you want to zoom in, just select a chart and hit preview charts. Then it will be shown in a bigger size. So total cost by scenario, you found base scenario is best. Like you don't need to add any new trunk line. And based on percentage rejected, 3 of the scenarios work best. Either adding a trunk line, adding like 39 trunk line, or adding 4 new two resources or new take all, so on. So just think about it. If we try all the combination, it will be very difficult to select the best one. That's why we need another application which is called OpQuest. In my next video, I'm going to talk about OpQuest for the same model. Thank you for watching this video.